Welcome everybody who's joining us for our first broadcast for the Hangout that's going to encompass weeks 1 and 2 of our MOOC on antibiotic resistance. And I'm here with Professor Didier Mazel. And also we have Beatrice Berceau, Dr. Beatrice Berceau joining us to answer some of the questions you already asked, in the forum, and also to address questions that you might have at this very moment and that you want to ask through the chat, or if you want to chat with us directly, feel free to do it. I'm going to start very quickly, and I'm going to address a couple of questions that pertain to the weekly test and questions that we have online. And so the first one was asked by Liz Pedrosa, and her question was, hi, I have a question regarding quinolone resistance. Videos show that quinolone resistance mechanism was modification of target enzymes. However, weekly test states that main quinolone resistance mechanism is something else. Could you help me? Actually, there was just a technical problem here, because if you read the question thoroughly, they're actually looking for the wrong answer. So it said, question 1 of weekly test 2 stated, among the following options, which one is not correct? And that's why we ended up choosing synthesis of quinolone reductase, which is something that doesn't exist, as the wrong question. All the other options are correct. And in fact, some of you in the forum noticed that, and I thank you for that. And so there's no problem with that. We'll keep the score straight. And just for next time, keep in mind that it's just we're looking for the not correct answer there. Similarly, we had Javier Meilan, who was addressing the checking knowledge section that was following week 2 as well. And he was concerned about question 2 that was after this particular session. And this one stated the following: among the following statements concerning the acquisition of resistance of gram-negative bacteria to aminoglycosides, same situation, we said which one is not correct. And that was the issue that we found. All the options were correct. For instance, gram-negative bacteria acquire resistance to aminoglycosides by mutation of the target. That's true. Gram-negative bacteria acquire resistance to aminoglycoside by synthesis of aminoglycoside phosphotransferase. That's also true. Gram-negative bacteria acquire resistance to aminoglycosides, because of the impermeability of the membrane. That's also correct. But the last one is not. Gram-negative bacteria acquire resistance to aminoglycosides by the alteration of DNA replication. So that's the answer we were looking for. Either way, thank you for raising this issue, and carry on with those tests and participating as you do, because that way we can find confusing points like this one and fix them on these sessions. So now I'm actually gonna let Dr. Beatrice Berceau handle a few of the most popular, most voted questions that we had on our forum. The first one was posted by an anonymous participant, and the question goes as follows. Hello, I am very interested in knowing how resistance to carbapenems in animals was generated, since these antibiotics are only used in humans. It would help me a lot if you would give me information about this topic. So I'm gonna give the floor to Beatrice so she can answer this particular question.
So thank you, Sebastian, and thank you for all to look our MOOC. We are very happy for that. And for these questions, first, I would like to say that enterobacteria producing carbapenemas isolate in animal are mostly due to transmission. So first, there are a bidirectional transmission from animal to humans, but also we have the opposite. It's also true. The animal could be contaminated by contact with human. So for illustrate that, for example, we know that in Porsche, they can carry MRSA. It's the same with Enterobacteriaceae and carbapenem. And we have also many publications that show that companion in contact with a human could be colonized by the same isolate. So this is the first answer. In addition, the second is the contamination could occur in animal when the area is polluted, for example, the floor and the contaminated food. And in this context, if the animal receives antibiotics, not carbapenem, for example, but instead it can be aminoglycoside or sulfamide. In that case, animal can select the strain resistance in their microbiota. So it's not necessary to have carbapenem and to have strain resistance. We can select a resistant strain if you have antibiotics, because it can explain by a co-carriage of plasmid in a strain, and the carriage of resistance together can select the bacteria resistant to carbapenem. So it's this is my answer. I hope that it's enough.
And yeah, if you don't mind, Didier would like to add something for that particular question.
In the same line, I mean, in many cases, it's the resistance are carried, at least in gram-negative, within integrants or complex integrants. And when you select, exactly as mentioned by Beatrice, if you select for one specific resistance, you co-select for the other genes that are carried within the integrants or in the complex integrant right next to the integrant. Thank you.
Great. So if it's okay with you, Beatrice, we'll move on to question number 2.
Yeah.
So this was asked by Sialu. Her question was, hello, I didn't understand why genes for beta-lactamases are mostly located on mobile genetic elements. And this explains then their widespread presence in gram-negatives.
So I have a short answer on that. So the resistance in gram-negative bacteria are usually due to a carriage of large plasmid. This plasmid can occur in Enterobacteriaceae, Pseudomonas, and Acinetobacter, for example. And this plasmid gives an additional resistance to the bacteria. These plasmids spread between gram-negative bacteria by a conjugation mechanism. And in that case, it can spread a lot between bacteria, and a unique isolate can carry several plasmids. So it's because of that, gram-negative are mostly resistant to beta-lactam. So if Didier have an additional thing for that?
No, I'm fine.
Okay.
Great. And if may I remind to everybody watching, if they have additional questions, make sure you post them on the chat.
Yes.
We're looking out for them out here, so don't be shy with those. So if it's okay with you, Beatrice, I'm going to move on to the last question on your section, and I'm going to do my best to translate it to English real quick.
Yeah.
So this one was asked by Mrs. Draman Yemde from Burkina Faso, and she's doing a master's in microbiology, and she just wanted to see some reasons, have some explanations for the emergence of ESBLs that rose in the European Union after 2006.
Yeah. First, I would like to say that it's not this time the emergence of BLSR. So it's the emergence of Enterobacteriaceae producing extended spectrum beta-lactamase occur before 2000. The first beta-lactam hydrolyzing enzyme were either TEM or SHV enzyme. Then, under pressure of selection, additional mutation occur in this gene, and the TEM protein and SHV protein can be able to hydrolyze the third generation cephalosporin. So in that case, it was before 2000. After, to answer more your questions, in 2003 and 2006, we have shown that mutated protein, TEM protein and SHV protein became less prevalent in favor to the appearance of SCTXM enzyme. In that case, we are now mainly, these enzymes are mainly responsible of the resistance to third generation cephalosporin in gram-negative bacteria. And these enzymes were mobilized from their progenitor, the progenitor is an Enterobacteriaceae called Quivera, sorry, and this enzyme came from Quivera to the other Enterobacteriaceae with they use the international sequence ESCP1. This sequence catches gene from the progenitor and diffuse it on plasmid. And this plasmid was diffused between Enterobacteriaceae. And this gene is now very prevalent in gram-negative in the hospital, but also in community. And we can show now a successful clone in observe. It was in the E. coli ST131, and this clone was successful in the world and produced the CTXM enzyme. It is because of that you have now a large proportion of this enzyme in the world because of this successful clone. So this is my story, and if Didier want to say something additional. No?
No. I'm satisfied with your answer.
Yeah.
So.
Thank you. I hope that all can be satisfied with this story. So.
Great. Thanks so much, Beatrice. Please do hang around in case we get some additional questions. And now I'm going to give the forum to Didier, who's going to deal with a few more questions that were posted. The first one of them that was asked by Dalia Lau. Is there actual evidence of antibiotics working as growth enhancers in animals? And if so, do we know anything about the mechanisms?
So I will try to not be too boring with that. So the short answer is yes. There are very strong evidence of the use of antibiotics as growth enhancer in animals. It has been established very in the late 80s, and it has been backed up since then by many studies about that. So it's the way they work as an answer has not been firmly demonstrated. So it has been proposed that you can, even at low concentration, because the concentration that are used in this condition when you use it as enhancers are much lower than the therapeutic concentrations. And so the effect on the microbiota has not been extensively studied, but it has been proposed that you can decrease, that it can play a role to decrease the inflammation in the gut of these animals, and that it can also limit or play a role on the complexity of the population, and that it can limit, especially that it can limit the microbial fermentation. And that has been shown to induce a better uptake of the nutrients by the animals, and then to give them an advantage, a growth advantage. But this has not been really, so the extent and the contribution of these different mechanisms is not yet completely clear. But this is the two kind of explanation that have been proposed and partly validated for the role in this condition. However, I mean the use now of antibiotics as a growth promoter is now so important that alternate solutions are tried to be put in practice, and in many countries this has been banned for growth promotion. I hope that was clear enough. At least it's what we can answer to this very important question.
Great. So next question for Didier. It's more of a statement posted by Alba B, but an interesting one nonetheless. As history has been telling us, in the antibiotic-resistant arms race, bacteria are constantly winning. We release a new antibiotic to the market, and it takes a little time to detect first cases of microbes resistant to such antibiotic. Isn't it high time to develop alternative therapies, or at least antimicrobials which targets are different?
So that's indeed a very interesting and very clever observation and question. And but you will have to be patient, because it will be there are indeed currently the development of creative alternative that can bring new ways to treat infectious disease or bacterial disease, but they will be described in the last sessions of the MOOC. So in the last week, you will be able to learn all about the alternate technologies or alternate approaches that are currently that are being developed and that are currently being tested.
Great, and we got one more question for Didier in this particular Hangout for both first weeks of our course, which was asked by Ana Maria Salinas, who is currently in a PhD program in Quito, and she's wondering how the EU has been avoiding the use of antibiotics for growth promotion, and nevertheless has still ESBLs, excuse me, and other resistance genes. She wants to know where they're coming from, actually.
So I will just recall what has been, I mean, the part of the answer has already been provided by Beatrice in response to the previous questions. So, so what I can say about is more about the fact that even though antibiotics are no more used as growth promoters, we still see the development of antibiotic resistance. The problem is not that simple. I mean, the resistance phenotype and the genes involved in resistance are not are rarely coming from the animals to the humans. So there are many other. I mean, we are by ourselves. We are sufficiently efficient to select for antibiotic resistance, and so there are some kind of discussions about the origin and the gene trafficking between animals and humans, but it's much more complex than that. So we have many occasions to get access to new resistance genes in our food, not only with the meat, but with vegetables, fruits, the many environment that where you find human beings can be the source of resistance genes. Unfortunately, if it had been that simple, I mean, if we could just by preventing the rise of resistance in animals, we can save human beings from resistance, that would have been extraordinary. But it's not that simple. But it's a good point. We can limit at least it has been the case for the glycopeptides. So there are it's clear that you can co-select by using some antibiotics in animals. You can co-select for resistance that are efficient from the antibiotics that are used in human medicine. So we have to get better practice and limit this kind of use. But it's not sufficient to prevent the appearance of resistance phenotype.
Great. So that, for the time being, covers the most voted questions in the forum for these two first weeks. You still have, we'll give you a few minutes if you want to contact us directly right now during this Hangout through video or through the chat, you have an impromptu question that you would like to address right now, we'd be happy to take it. So think about it for a few minutes. Meanwhile, I'd like to encourage you and remind you, I think we've been a pretty active community on the forum, which is pretty exciting. I think we've done great in that respect in the first 2 weeks of this particular course. I'd like you to stay that active. I'd like to remind you to vote for the questions that interest you the most, because that is what truly helps us select them and address them in these particular sessions, so we can serve you the best we can. And yeah, just stay curious, just stay active, and it's been great to interact with you on that forum. And I'll also like to take this particular opportunity to thank both Dr. Beatrice and Professor Didier for joining us in this particular Hangout. And unless our colleagues here in the group chat or online don't have any more questions, I think we'll thank you once again for tuning in, and we'll say till the next time, just keep firing the questions and we'll do our best to answer them.
Sure.
All right. Thanks to everybody.
Thanks. Bye-bye.
Bye.